Now we'll see another problem on various sections. So let's see the problem number 10. So the question is, the bar is subjected to a tensile load of 160 kilonewton per meter, or 160 kilonewton, if the stress in the bar in the middle portion, so he's asking stress in the middle portion of limiting or limited to 150 kilonewton, right? So he's asking to determine the diameter of the middle portion and also find also the length of the middle portion. So he is asking to find out the diameter, right? Diameter as well as the length of middle portion. So this is how it looks. So is applied load of 160 kilonewton, right? So the total length is given, that is 40 centimeters. So dia of this bar is 6 mm. Let's say dia same as 6 mm. So these two are same. These two are same. Let me draw it properly. So we need to find this portion, that is middle of this portion. So we need to find the dia of this portion and as well as the length, right? So come back to the question. To find the middle portion, find the length of middle portion if the total elongation of the bar is to be 0.2 mm, okay, and the Young's modulus or elastic modulus is given as equals to 2.1 into 10 to the power of 5 Newton per mm square. Right? This is a question. So let me repeat it. So the bar is subjected to a tensile load of 160 kilonewton. If the stress in this middle portion is limited to 150 Newton per mm square, that is, the stress is given for this middle portion, that is 150 Newton per mm square. Determine the diameter of the middle portion. Find also the length of the middle portion. If the total elongation of the bar is to be 0.2 mm, that means total elongation, total extension or stretch of this bar will be 0.2 mm, and the Young's modulus is given equals to 2.1 into 10 to the power of 5 Newton per mm square. So let us write the given data first. Right? So given data, the tensile load, that is given P is equals to 160 kilonewton, right? So the tensile load is given. So convert into newtons, that is 160 into 10 to the power of 3 Newton. Okay. Next, the stress is given, that is stress in middle portion. Stress in middle portion, that is sigma 2. Let's say sigma 2 will be 150 Newton per mm square. Right? So now the total elongation is given. I can write total elongation dl, that is 0.2 mm. Right? Total elongation is given, and total length of the bar, as we know, and the total length is about 40 centimeters, right? And 6 centimeters there on each side, right? The total length of the bar L is equals to 40 centimeters. Convert into mm, it will become 400 mm, right? And the Young's modulus E is given, that is 2.1 into 10 to the power of 5 Newton per mm square. Dia of both ends, this one and this one, is given, that is end portion T1 is 6 centimeters, that means 60 mm. So now we'll find out the area. Hence the area of the cross section of both end portion will be, let's say A1, that is pi by 4 d square. So what is D? Here D is 6 centimeters, that means 60 mm. We'll put the value here, and the A1 area will be 2827, right? 43 mm square. Clear? Now let dia of second portion, that means the middle portion, let's say D2, we have to find out. D1 we already given in the question, that is 6 on both sides, on the both ends. So let us find out the dia of middle portion. Yeah. Let D2 diameter of the middle portion and D1 both the ends, or let's say L1, we have to find out the length as well, right? So L2 is the length of the middle portion. Okay. So let us consider this as L1 and this portion as L3, because the middle portion will consider as L2. So let's say for this end L1 and the middle portion, let me highlight it, will be L2 and the last one is L3, right? So now I can write L1 plus L2 plus L3 will be 40. Total length is given, right? So now I can find out from here L1 plus L3 equals to 40 minus L2, right? So that will be the, from this we can get this. Now strain, we know that load on area from the middle portion, stress is already given. We have sigma 2 equals to P upon A2, right? So that is A2 equals to, let's find out A2 first, pi by 4 D2 square. So we don't know D2. So let us put this value here. So stress is given 150, right, into 160 into 10 to the power of 3 upon pi by 4 D2 square, right? Okay. So to do this, we can find out diameter. That is from here we can write D2 whole square, that is here, equals to, I'm sending this 150 on right hand side, so it will be 4 into 16,000, 1,60,000, I will write here 4 zeros upon pi into 150. So d2 equals to under root. So from here we get 1358 mm square. So square root on both sides, we'll get 30.58 mm. So that is a d2. So we got the d2 here. Now we'll find out the length of the middle portion, or is the area of middle portion. Right? I can write area of cross section, of middle portion. Okay, so A2 will be pi by 4 d square, right? Pi by 4 d square. So we got here the value pi by 4. Substitute this value here, will be 30.85. So we get A2 as 1066 mm square. So we got the area, we got the diameter. Now we know the total extension formula, that is dl equals to p upon, so we'll write here total extension dl will be equals to p upon Young's modulus L1 plus A1 plus L2 plus A2 plus L3 plus A3, right? And we know that the area 1 is equals to area 3. So because the cross section is same, A1 equals to A3, right? So that will be P upon E L1 A1 plus L2 A2 plus L3 A1. So in the place of, instead of A3, I am writing A1 on both ends, right? So if you write here P upon Young's modulus is into L1 plus L3 by A1 plus L2 by A2. So we are going to find out the length. So we know that L1, right? And you can write here P upon E is equals to the total length is 40 minus L2 upon area A1 plus L2 A2, right? I can write this as total minus L2. So L1 plus L3 I can write as total 40, that is the total length, minus L2, so that we can find out L2, right? Yeah. So we know the total extension, that is DL, is given in the question, right? That is nothing but 2.5, yeah, that is equals to P. We know that Young's modulus is given, put the values here, 1,60,000 upon 2.1 into 10 to the power of 5 into, put the values 40 minus L2 upon, we know the area 1, that is 2827.43, right, plus L2 upon the value, we know that area 2 is already got it, put the value here, that will be 1066. So do some math here. 1.6 into 10 to the power of 5, 2.1 into 10 to the power of 5, cross multiplication, that is 0.1066 into 40 mm minus L2 upon plus 2827.43 L2 upon 282,743 into 1066, right? So now from this we can get 0.761 1066 into 400 minus 1066 L2. So multiplying this with both will get this plus 2827.43 L2, right, upon upon 282,743 into 1066. So here we know that we are finding the total elongation, the total extension, that is 0.2, right? So here I can write 0.25 upon 0.76 equals to L2 is same, so we'll get 0.2628 here, and this will be same. Send this on right hand side, so we get from now, so we'll get this as 0.2628 into, send this here on right hand side, so left hand side it will be 2827.43 into 1066, that is equals to here, how much is this? Will be 426400 minus here 1066 L2 plus 2837.43 L2, right? So if you put this on your calc, it will become 792089 equals to 426400 minus 1066 L2 plus 2837.43 43 L2. So put the value in the calc, take the L2 common here, so it will become, send this value here, it is 792,089 minus 426,400. L2 will become common, minus 1066, right? So from here we can know that L2 equals to 365,689.1761, that will be 207.65 mm, and L2 will become 20.765 centimeters. This is how you can find. I just elaborated the mass part, but you can directly find by using calc, no problem. So now we got the L2 as 20 centimeters, right? So once we put the values, it's better to draw again in the exam point of view to mention all the, this is 6 centimeters there, centimeters, and the total length is given, that is 40 centimeters. Now we found out the length of this portion as well as diameter, right? So length of this portion is 20.76 centimeters, right? The next lecture we'll see the principle of superpositioning, and we'll do problem on principle of superpositioning and how a bar is having different cross sections and different axial loads, right? Thanks for watching.